Hello and welcome back to another video. In this problem, we're told that the graphs of f and g are shown, and we're asked to decide whether each function is even, odd, or neither, and to explain our reasoning. So the definitions of even and odd: an even function is one such that f of x is equal to f of negative x, and in an odd function, f of negative x equal to negative f of x. So now we can look at our functions here, and let's start with g. So we can notice that g is symmetric about the y-axis, right? If we split it down the middle, it looks the exact same on both sides of the axis. And what that means is that for any point, let's say this point right here, let's call this a, b, right? For some particular x, a, and some particular y, b, there's a corresponding point here at negative a that also is at the value of b. So therefore, f of a is equal to f of negative a. They're both equal to b, therefore g is even. If we look at the points at a and negative a on the graph of f, we can see that it's this point here and this point here, roughly. We can see that f of negative a, which is, let's call it c. Actually, this can be c and this can be negative c since it's above the x-axis. This is equal to negative f of a. This is negative c, which is equal to negative the value of f of a, which is c. This is because it's symmetric about the origin. This point has a corresponding point. This point has a corresponding point. All of these points have corresponding points where, let's say this point and this point, they have opposite x values, right? The x value of this point is the negative of the x value of this point. And the value is the same. This point is the negative value of this point. So if f of negative a is equal to negative f of a, which is equal to negative c, then f is odd. So g is even and f is odd. This is how you look at it graphically without actually knowing the specific values of the function at any given point. Looking whether f of x is equal to f of negative x, or if f of negative x is equal to negative f of x.